this is the kind of overview that I started to go into yesterday. And I said at the point of showing you guys these very early either projects or experimentations we did at Lumena was to start to get our feet wet when it comes to actual VR implementations. And I mentioned that they're not going to relate, of course, one-to-one with all of this theoretical stuff, but that it's useful to just get going with what exactly can happen and start to understand the problem space that's specific to VR. So let me get into the first one. This one, the one that I call Fix the Gap, this is coming from a VR project that we did for a big multinational healthcare company called B. Brown. And they do a bunch of stuff. They do all sorts of products and equipment needed in hospitals and all areas of healthcare. But they had a particular department that was focused on what is called SSI. So that stands for surgical site infections. And what B. Brown is producing is a set of disinfectant products that are used in surgical wards. And the problem that they had is that the incidence of SSIs, of surgical site infections in the surgical ward, is absolutely huge. So here it says 0.5 to 10%, but there's like a note in there saying the real rate of SSI is probably underestimated. The truth is that this kind of rates is what we see in countries like Germany that have basically unlimited resources to throw at problems like this. As soon as we go even towards Central and Eastern Europe and then other parts of the world, this number jumps to around 30%, which is absolutely monumental. And B. Brown and other medical consortia around the world and World Health Organization got together to try to figure it out. So they gathered data in a bunch of hospitals and they tried to identify the problems and produce methodologies and all the usual stuff. Then they got training seminars and got staff in the surgical wards to teach them the potential causes of a surgical site infection in the surgical ward. And their diagrams looked like something like this. And basically every color represents a different area in the parkour, in the route that a patient goes through in the surgical ward. So it's divided into before surgery, during surgery, and after surgery. And all of these things basically happen in very distinct areas of the hospital. And every vertical represents a different person. And every square represents all the contact points at which that person could make a mistake that could lead to an SSI. But this is not even the whole story. I'm just showing you a little bit. It's not like this is it. It's the type of glove that you wear matter. The person that you touched before you enter a certain room matter. If that person was coming or going out of a particular room matters. The kind of object that you touch before you put a certain disinfectant on your hand or on your patient matters. The way the blankets, those warm blankets that cover the patient, the way those were stored and who touched them, like which of these people touched them and which disinfectant these people used on their hands before they touched the blanket matters. So although they did the best they could to get this into the hospitals and train people, the incidence of SSIs would not budge. And it was just driving everyone absolutely nuts. The head of this department from B. Brown, the woman who was also the project manager for this project on the client side, her father was a head surgeon in a major German hospital, and he needed surgery. He had his own team operate on him in the absolute best conditions of hygiene, and he ended up getting a surgical site infection, and also because of other things, in the end he passed away. So even the project manager had a personal story of this happening. That's how high is the recurrence in a country like Germany. So when they came to us, they said, okay, we tried these diagrams, we tried videos, we tried everything, we just cannot improve the situation. It's not about money, it's not about budget, it's not that we're not doing it right, we're following all the protocols. Everything that we're producing is quote unquote correct. How do we fix this? And when we took a look at it, the first thing actually that we saw when we began to understand the problem was from the perspective of us being architects. So we saw all of these things actually laid out in space, and that space being the complexity of the surgical ward. So for us, one of the missing pieces of the puzzle immediately was the fact that this is actually a spatial layout and is nowhere presented as a problem that has to do with a complex spatial layout. And the second thing we noticed is where these diagrams are falling short, and because they're falling short, you need a second one and a third one and a fifth one, was that there is no understanding of the progression, of the proper progression in time, aside from these three main timeline categories. And there's no understanding of the relationships between these people, the potential touch points, and again, where are these people at that moment in space? In where exactly in the surgical ward are they? Where did they come from, and where are they going? Because we discovered that was very much part of the story. So overall, our conclusion was that this is failing because in order for them to quote unquote solve the problem, know what's causing this SSIs, they had to use this kind of very high level of abstraction of a very messy physical environment. And when they presented the staff with this level of abstraction, the staff was not able to take this crazy amount of information and spatialize it again. They were not able to, there was just too much for their brains to know how to properly apply it back in reality, back in a situation with zero level of abstraction. So we were dealing with a failure to understand that the spatial component was a significant component of this problem, a failure to understand that relationships in space between the actors, which is something, again, very architectural, was not something that was taken into account. And there was also a failure to recognize that traditional media like this diagram abstract information, and there is too much cognitive effort that is needed, or that we're asking hospital staff to spend to be able to decompress all of this and apply it back in reality. So sometimes you hear about these things as the traditional gap between theory and practice, but this has become a bit more of a cliche. So this is like a specific example of that. So we attempted, and luckily it worked out, but we attempted something we weren't quite sure we're going to succeed at in the beginning, which is to map out and model and run an entire surgical ward on the Quest, because they wanted to run this application on a Quest, which is a standalone device. And we, for that, we spent a few weeks working as architects, actually, with the staff from B. Brown to get the proper spatial arrangement between all the different parts of the surgical ward and understand the movement of patients through the different areas. So what you see here is almost, there are a few more rooms in the lower part of the image that are not in, but all you're seeing here are the different the main parts of the surgical ward. So we only have one operating room, which is on your left, with a room that the patients go in, another one the patients goes out. So a normal ward would probably have even higher complexity with more than one operating room. And we did not have any step-by-step instructions of how to do this. The idea is that we let the people go in and just do things, and we only gave them feedback when they did something right or wrong. Like in this case, it's showing the correct choice, but we also had a run where you're only being told when you did something wrong. So you're just given the idea was that you would develop some kind of intuition by keep going through this hospital and trying to touch things and trying to understand it that way. But of course, there was also text and other kind of stuff you could read about it. And there was an interactive map, and you could jump from one station to another, or you can just roam the hospital free. And the other thing that was important for us that we experimented with, it was very important for us to really drive home in a visceral kind of way for every user what role they're playing, because the role that you're playing radically changes the way you have to think about disinfection and what product you're using. You're touching different things, you're going different places, you have contact with patients in different way in different areas of the patient, with different objects around the patient. So instead of just making a button, right, that shows, okay, now you click this button and you become a nurse, or now you click this button and you become an anesthesiologist, we actually had these animated characters that were sprinkled around the hospital. And if you wanted to play their role, you would have to go near them and literally jump into them. Sounds a little bit freaky, but you would actually jump into their skin. And then you would see the UI around your hands, and the color of your gloves change to represent that. But we wanted this little bit of like freakiness to really heighten the moment that you have just become this other person. So then you can go around the hospital and you can jump into any character that you see, but this jumping in and this switching of the skin like zombies became something that was really pregnant. Like people were really became aware and could not forget, okay, who am I now? So this hospital was also became like a strange role-playing kind of environment where you're becoming all these different people. Sometimes you also interact with them. Sometimes they tell you things. We got a bit of voice acting to make things even more interesting. But yeah, we tried to add as many layers of messiness and potential uncertainty as to who's that guy, why is he there, should he be there, should I go there, should I not go there? So as much mess as possible. So this was the first example that I'm calling fix the gap. And for me, this is also a little bit an example of how something like VR, because of its immersive nature and because it's allowing us to do things like walk around this hospital and jump into doctor skins, it's highlighting it's using exactly what makes it different from videos and diagrams to solve things that videos and diagrams fall short in solving. And this is exactly what we're interested in as a company. So we're not doing any more training VR apps that are about helping you do something better or substituting the physical kind of training that you just happen not to have. Those are absolutely amazing, but we're interested in these things that have the potential to solve problems that other media absolutely could not. The second the second approach to thinking, like conceptualizing the VR world and the interface, is the one I call visualized relationships. And I mentioned this yesterday, I'll just repeat it briefly. We have been working for a while on a VR application that allows you to move walls around and design mostly small to medium size buildings. And there is there's a need to interact with elements that are just huge, like building scale elements. And nothing about that feels natural because we just do not do that in physical reality. So we had to come up with, and the thing people would tell us again and again is main operations like rotation and translation of these big objects do not feel good. And then we had to kind of keep asking, well, what do you mean by does not feel good, right? Because sometimes that's also the kind of challenge that we have with talking to testers with VR. You know, they're not, I guess we all do not really have the proper vocabulary to talk about these things, because normally when you test other kinds of applications, it's much clearer. Okay, he clicked on the wrong button, or he didn't know where to find that function and click, or he didn't go to the menu and then file and then whatever, that's what you need. We're dealing with a complete different spectrum of issues. So we're asking people to describe how movement in space feels like, which is like, what, like under what other kind of circumstance do you ever do that, right? It's like sports class in like 7th grade, I don't know, where they ask you like, how did it feel when you jump over that thing? But that's exactly the kind of stuff we're dealing with. So people are like, it didn't feel good for me to move the wall. And we're like, okay, what exactly does that mean? And we kept going in and trying to dig deeper, and we got to the point where people said it did not feel comfortable. And then eventually they said, it did not feel that I'm in control. And the moment they said that, we're like, okay, now we're onto something. Like, this is something that maybe we can work with. And this is where all of this reading that I've been doing with trying to understand the way thoughts work and cognitive neuroscience has been very useful, right? In me trying to hone down what does it mean for someone to feel like they're not in control. Because again, the normal context we talk about a person not being in control of something is not usually like software, right? Or buttons, or doing something like a productivity software. It's very different kind of context. I need to find a better picture for you, but is this, check it out, it's playing. Perfect, the video is playing. All right, so on the left is a first take on rotating a cube from a distance with a laser. And if you're thinking right now, I hate lasers and interacting with lasers in VR is dumb, call that thought, because we're going to get to it. But in this particular case, we just had to have a way for you to move a cube that's like 50 meters away. And if you have a better idea of how to do that without a laser, let me know. So you do have a laser that shoots to that object, which is in the distance. The main problem is that it's not within the active, is not within the area right around your hands and arms, right? Like, that's the area that you have most control over and you feel most comfortable, like manipulating objects with your fingers and your hands. This thing was far away and you had to touch it and select it with this laser beam. And then we just put a gizmo on it, and you're supposed to grab the gizmo and just kind of rotate it. And this is where people were like, it does not feel good, I don't like it, and eventually I'm not in control of it. And what we tried to do, if you look at this, the image on the right, we tried to, so when we tried to formulate a theory as to what's going on and how we could fix it. and the hypothesis is, if we implement this and people report that they feel more in control, it means our theory was right. We said the eye does not have a good understanding. There's no, because the object is so far away, somehow the eye is not properly connected to the movement of the hand. So if we could visualize for the eye what is actually what is the outcome of the hand movement, maybe we get more integration that way between the eye and the hand. They're more at peace with each other, and then they transmit, or this feeling of increased comfort somehow appears as an emotion in our users. So on the right, there's the laser beam on the right here in the image, and then there is another line that basically connects wherever you're taking the laser beam and puts that on a dial. I know the cube on the left looks like it's moving very fast. They're actually moving the same. We did not change anything on the mechanics of how you're using, so there's not a different correspondence between movement of your hand and movement of the object. Is just this addition of extra visual understanding, and it worked. So moving this cube now feels totally cool. Feels like you're completely in control. So this is what I mean: visualize relationships, but you should not be doing it randomly. When you run into an issue like this, you should first try to hypothesize where the cognitive challenge, if there is one, might reside, and then how that might be fixed. Because sometimes sometimes there is no cognitive challenge. Sometimes the way you coded that movement is just shit, so you should just like recode it. Sometimes the solution comes from somewhere completely different, like this. And this is where we've also struggled with programmers that are traditionally trained as programmers, right? Because they are not trained in school, at least the one we had to deal with so far. But most of us are trained as architects that have learned programming. So we're trained to go and find other potential causes and hypothesize in many different directions. But we've dealt not on this problem, but similar problems with just traditional trained programmers who were not able to think outside, oh, there's something wrong with the code, or I should like lerp from there to there in a different kind of way. And then you just don't get far, then you end up with teams that just endlessly improve the smoothing, the snapping, the lerping, and then, it's still not great. I see Carly's partly in agreement. Okay, this one. So this is a screenshot from the same application. By the way, this is an application that is currently still an in-house tool that we use, but we are trying to get our shit together and get a public version of this application, so other people are using. We're making progress, but we're still slower than we would have liked to be. But basically, what I showed you before was just a very small detail of some of the interactions in here. Now I want to tell you what's the main concept, like what's the main organizational structure and idea behind this app. So everything in the scene exists 2 times. So every single element in the scene, including you, has a duplication. We're calling the little u mini-me. So you exist at 1-to-1 scale, and then inside this box here, which we call a sandbox, you also exist in here, and that's the mini-me. And you can grab any element either at the 1-to-1 scale or inside here, and the corresponding element will also move. This is also our main locomotion. if you want to go somewhere, you grab yourself and you just drop yourself in another place. So it gets a little bit meta. In technical terms, what in architecture we call the bird's eye perspective, or like God's view, in psychology is called the allocentric perspective, and the opposite of that is the egocentric perspective. So what we call bird's eye view and the phenomenal experience in architecture and design, they call allocentric and egocentric. And the interesting thing in reading texts on these two perspectives in psychology as opposed to architecture, aside from just how fun it is to see different disciplines describing exactly the same thing in totally different ways, is that the psychologists are of course they're very useful because they actually do studies. They collect data and they try to organize that data, which as architects we do not do that, right? We only do what's called architectural theory, which is just talk. But where I want to go with this is I've been reading some studies on allocentric versus egocentric perspectives of the individual, and it turns out that in daily life, on a daily basis, when we describe to other people locations or we give directions, we continuously switch between allocentric and egocentric. For example, we would describe to someone how they should go to, like a new person in town, how they should go to the supermarket. And we would say things like, you should walk north 2 blocks and then turn east, and then you will see a house with a blue fence. And we do that routinely, right? So go north 2 blocks and then east is the allocentric guide's view perspective. And you will see a house with a blue fence is the egocentric perspective. So this is actually is not an exception. It's something we do all the time, and other people understand us. So we continuously switch between us being in the center of the description and the center, like we are the center of the world we're describing. And all of a sudden, we pull ourselves up and we switch in the same sentence to using most of the time like cardinal directions. And we're able to put other actors in there. And that in itself is fascinating, right? So they've been looking at these things happening in the brain, and the more even more fascinating stuff is that we throw this mess on other people and this shift of perspectives, and other people have no problem following and understanding what we're talking about. So this was a bit of a parenthesis, but I wanted to have this set up for this application because of architectural reasons. And in architecture, like what I said, we call the one-to-one the phenomenal perspective, because it allows you to have an understanding of things that are not very rational, but still very much important in architecture. Like, is the ceiling too high? Is this room the wrong proportion? Is the quality of light that comes in at 5 p.m. Right or not? So those things you can only have by being in there one-on-one. And this is also running on a quest, and we went through absolute hell for about 1.5 years trying to get real-time shadows to run. Not a parenthesis, but they're running now. And so you make those decisions there, but then of course it's architecture, so you still need the allocentric perspective to understand the logic of the entire structure. So in that case, you will reach to the little twin version in here. And we've noticed designers very fluently kind of going back and forth. So sometimes they reach to the big thing, sometimes they reach to the little one. And what resulted was a very interesting and unique kind of workflow This is very different than modeling in your 3D tool and then sending the VR to the headset and then coming back in the modeling tool and fixing it. And we were very gung-ho. And again, it took us tremendous technical effort to make sure that we can display both the two twins simultaneously. There are other architecture, actually there's only one architecture tool out there that is doing one-on-one, I think some type of one-on-one modeling, but they make you, I think last time I was in it, they make you switch. So they make you choose, like either you're in at one-to-one or you exit that scene and you are in an empty scene with a little miniature. So you can't do them simultaneously. But for us is this, and of course for technical reasons, and we know why, but for us, it was worth dealing with the technical hurdles because this was so central. So this is what I mean by change the world. I mean, try to see if you can still achieve quote unquote practical results or workflow that can produce results, but have a very different underlying logic of that environment than the logic of physical reality. So having a duplication of everything and being able to manipulate the scale of those twins independently and then still have them linked is something that couldn't be more foreign from our actual reality. Like even if you close your eyes for a second and you imagine that, you know, this keyboard in front of you, you just had a duplication of it. In the beginning, like I think that your first thought might be, well, but why? Because I already have one. Why do I need another one? But then if you think about it for longer, I think you'll find many, many cool things that you could possibly do with the second one. And maybe not just the keyboard, but other things. So we just do not have those possibilities. But the fascinating thing is that the moment where you introduce that possibility, people find ways to use it differently and do things to these two scales. And of course, the best part, the mini-me, which is in actual reality, you cannot pick yourself up and drop yourself somewhere else, but here you can. And it's here it's a bit of a psychological trick that we did. There's an application like Museum of Other Realities, for example. When you're in their lobby, they have a map and you can shoot a teleport beam inside that map and you will then pop up there. In terms of the code and the logic of how that works is kind of similar to what we have. But at the psychological level, we're actually showing a little person that is supposed to be you, and you move your hands and the little guy moves their hands and you actually grab them up, and we want to make it so that they like wiggle their feet. They wiggle their feet when you grab them up. So it's like a Gulliver and like Lilliput kind of thing. And there's just something so, I don't know, slightly jolting at a psychological level that happens. So maybe this connects a little bit to the storytelling thing that we kind of started to talk about at the end. So if for me, if there's any point in including storytelling in here is this kind of stuff where the implementation from the point of view of code is the same, but the psychological impact of seeing yourself, grabbing yourself, pulling yourself up in the air, seeing yourself like struggle to escape, and then dropping yourself in a different part of the world, and then finding yourself there, is something worth exploring in terms of psychological power. And this is okay. So this is, I think, one of the most out there things that we did so far. It's not, we call this one our most spatial menu yet, but it's just the first instantiation. So don't get scared. It's not going to stay like this. But I do think it's been the kind of big step in the direction of exploring metaphors for us. So like I said yesterday, the use of metaphor in UI design is still the main paradigm, although many people do not recognize. We still use icons that are an abstraction of an object, magnifying glass, pen, pencil, stuff like that. So the core of the metaphor theory in UI is that there are features of the system that map into the features of the metaphor. So the metaphor being something that maybe an object or a procedure that maybe you are familiar with from physical reality, that becomes a vehicle that then brings you familiarity with features of the system being the part that you're not familiar with. The tricky thing, and all the many papers that were written and are still being written on UI as metaphor, is that there has to be a mapping, right? There has to be a mapping, and it's very hard to find the perfect mapping. With the manila envelope, that was like kind of lucky. But when you go into more complicated things, some things will map between the metaphor and your system. But if the metaphor is something, let's say like an object, there are not that many simple objects, or if the object is too simple, it's not going to serve you much because your system might be complicated. Otherwise, you wouldn't need the metaphor. So if you are recoursing to this strategy, it means your system is fairly complex. So you need fairly complex objects to serve as your metaphor. But if those are complex, they will have some things that will map to the system, therefore help you, but very likely other things and other associations that will have nothing to do with the logic of your system and will like mislead people when trying to use your system through that metaphor. So we went like bananas with this. We said, okay, let's just have fun. But you have to look at what I'm showing you from the point of view of this metaphor. A lot of people looked at this and they said, okay, this is skeuomorphism. But first I'll tell you what it is, and then I'll tell you why it's not skeuomorphism. So our most spatial menu yet is basically this. It's an infinite vertical wall of storage containers, and each of these containers is holding one of the scenes that you have created in our application. So maybe it's a little study of a house, of a building, or many variations of that, and you get a little preview on the screen. And you go up and down on this elevator that has two infinite axes, and you have a little joystick, and you sit there and you can just go up and down and left and right infinitely along this wall. Now this elevator is terribly dystopian. I personally love it. It is inspired by a communist building from the former Czechoslovakia. It is the national insurance company, and they actually had an elevator that was working on this principle. And you would have these women plugging in the location on the grid, and the elevator would move in two axes just like this and take them there. And at the time, it was considered something like 20% or 30% more efficient than the regular systems. So it's very much dystopian. It is not skeuomorphic in that those elevators were not like going up and down endlessly. And so what were we going after basically? Because this is a bit of a crazy thing. This is a first attempt of us trying to answer questions like, are you gonna start to use this basically as a whiteboard to arrange your things in certain way, to group them in certain way? And if we start to add smart tags that will allow you to automatically, based on tags, reconfigure what these things look like what's the potential of that? And we're even considering right now basically creating it's like creating a building out of this. Like I had people ask me to give them corridors so they can go in and like put everything in, but I do not imagine those corridors that start to go in like tunnels are fixed. They could be procedurally generated based on the tags. So you could want to create a corridor that is housing all of the scenes that have a specific tag, and then when you change the filters on your tag, that corridor will disappear and another one of a different shape will appear that's hosting a different selection of things. So so this is like the 1.1 implementation of a bunch of those ideas. And the second thing that I was very interested in is the idea of interacting with abstract objects or entities like files as if they were big physical chunks. So what you see here on the right is this what's the name, like a cartouche? Is that an English word? Like is it an English or like a it's like a VHS tape, but very big. Basically, it's almost like a military kind of thing, and that's where your
cartridge.
Cartridge, yes, cartridge, yes. That's also the name we use for the ink in the printer, right? Cartridge, yeah. So this thing is kind of big and heavy and like kind of like military looking, and you can pull it out of the slot, like you press a button and it pulls it out of the slot, and you can look into it and you see this kind of like magical particle effects that's supposed to represent the universe, that the little metaverse that is housed in there. And then you can push this thing and the whole thing just goes like just slowly flops over and then just falls into the infinity of the thing below. And we wanted to see if that is creating any kind of emotional response, basically. And it is, it's making people have a different relationship to things that otherwise we how should I put this? I think I have yeah, here. So what you see on the left is basically our menu, because our menu is nothing else than just like a list of files. These are actually folders, like in our case it's just files. So we did nothing else than take those files and put them in this bizarre vertical wall, and then have this bizarre dystopian elevator that, by the way, makes the most amazing like screech noises as you go left and right. And somehow we show this to people and put them in, and I think some were like, what? Because it looks dystopian, but most of them were like, oh, wow. So I have all these files and I can fill in all of these things. And like, how many are they? And we're like, as many as you want. Just this way of displaying it. People were like so surprised. Wow, I can create so many worlds. Well, technically you can create as many files as you want in a Windows folder, but like no one really finds any wow effect in that. So we were very interested in that. It was almost a little bit like the scene on the right, where every little screen, rather than some boring little text file, every little screen is a window into a fully blown endless universe, which it is. You can go into those scenes and they're endless. You can do whatever you want in there. And then once you go through that, and then you go through the process of pulling this thing out, and it's like heavy and it has this amazing sparkling stuff inside and it looks like magic, and then you throw it down and then it's deleted forever. It just gives a level of drama that I was very interested in. So to recap, perhaps I haven't explored so much narrative yet, but I'm very interested, perhaps in a slightly perverse way, in playing with this kind of emotional effects, because I think in the right context, they can be quite useful. Yeah, and I think what made this so powerful is this feeling that you can go in front of any of these screens and there is an enter button and you enter it and all of a sudden you are in this endless Unity scene. And in terms of coding and the database, of course, that's nothing else than you just open a Word document. But the actual experience of being in front of this wall, pressing enter and being in this other world it's quite profound psychologically for many people.